I don't know if it's the same thing for you, but I tend to consider myself as a human. And as a human, I'm making mistakes. By the way, I'm sure you've seen quite a bit already. And I must admit that my Android applications do not necessarily do what I want them to do the first time I run them. And I think that's why God has created debuggers. So let's see what kind of debugging tools we have on this Android platform. First of all, we have the Eclipse Java editor. Then we have the Delvic builder, which is helping us a lot. We are going to see the Eclipse debugger, the logcat system, the ADB, the Android debugging bridge. We're going to use the DMMS perspective. And finally, we're going to have a look on the profiler. Now let's start with the Eclipse Java editor and maybe at the same time also the Delvic builder. Just to remind you, Delvic is this special Java machine running on your Android phone and also as well, of course, in the Android emulator. Okay, you already know that, and for the purpose of this demonstration, I reopened one of our previous projects, the Joshua project. What you already know is that the system, the editor, is helping you not to make mistakes. For example, here I'm creating a button, I'm looking for it with a find view by ID. I do R dot, and there is this help, this auto-completion. R.id dot, I'm creating a button. The only thing that is making sense here is my button. So here it's going to be very difficult to do a typo. The second thing, you can still make a mistake. Let's say you don't use this auto-completion, and here instead of using set on click listener, you type set click listener. In real time, you know that the system will show you a warning. So it's kind of compiling in real time what you're typing. And it's saying that basically this method, set click listener, is undefined. If I save this file, now I have this error showing in the problem tab here, showing me the line exactly where it is. If I double click, it's bringing me right where my error is. But here you have also a system that will again help you and will try to fix your mistakes. If you click here, see, the system is trying to see what would make sense here. Since set click listener doesn't exist, maybe you want it to say set clickable. That would make sense. Set key listener, set on click listener. Actually that was the one. So that is fixed. I'm saving and my error is disappearing. So you already have some help not making mistakes and fixing the mistakes you're making in real time. But sometimes that's not enough. What you have is not a syntax error, it's a logic error. So I'm going to show you now the debugger, the Eclipse debugger. For that, we need to make some mistake, some logic mistake. You remember the application? There's right here, there's three radio buttons, a red, a green, and a blue one, and depending on which one you click, it's changing the color of the message. And we've done that with a switch here. First, we have implemented a non-click listener on a radio button, and on radio buttons, the three buttons. And on this on-click listener, we are an object which is a radio button. Here it's a view, V, but we cast it in a radio button object right here. And then we have a switch. And depending on the ID, we use get ID here. Depending on the ID, we know that it's my radio button red, and in this case we turn the message in red, or a green one and we change the color for green, or same thing for blue. And of course here it's a case, so a good Java developer will add breaks here, one here, and it's optional, but one here as well. And you probably know that if you don't have a break here, if you forget that here, and let's see, we forgot it, what the system will do, what Java will do is it will go here and let's say we click the red button, so it will run this piece of code and turn the message red. And then, since there is no break, it will continue and go here and turn the message green, and then go here and turn the message blue. So let's make sure that this is really the behavior of the application now. So I'm going to save it, and I'm going to run this app. Here it is. So I'm clicking on red, and my message is not red, it's blue. Same thing for green, and of course same for blue. So we have a real logic error in our application, not a syntax error here. So we're going to go in the debug perspective here. Going to minimize this. This is the logcat that we're going to see in a few minutes. So you have a logcat panel here. You have the same property console panel as in the Java perspective. You have a view on your code here, an outline of your code right here. You have a debugging panel here, and you have two very interesting tabs here, variables and breakpoints. Because here, yes, we're going to set breakpoints to see what's wrong in our application. And that would be a good idea right here in this on-click listener. So you have three options here to create a breakpoint. You can go here in the margin and double click. You have a blue indication here, and see here as well we have a breakpoint on line 55 in the on-click method. What you can do also is do Control-Shift-B if you are under Windows, and with a Mac it would be Control-Command-B, and that will also set a breakpoint. And the third option is going, I think, yes, in the Run menu, and right here you have Toggle Breakpoint. And now we are not going to run the application the usual way with the Run As. We're going to use the bug icon here, Debug As. Debug as an Android application. It's installing the application. We see some activity here in the debugging panel. It's coming. I'm unlocking the phone. My application is here. You may have a message here, a pop-up message telling you that you have to wait a couple of seconds because the system is attaching the debugger to your application. Not a big deal in this case. Just wait 1 or 2 seconds usually. And now let's see what we have here. We have a view here in the debugger of what the system is doing and the different threads of the application. If I click on the red radio button, now the emulator is disappearing automatically, and you see here it's showing me exactly when it stops, where it stops, sorry, and it stops of course on my breakpoint, this one here. And in the debugging panel I see the backtrace of all the actions. What would be interesting here is making sure we're checking this V object here. So the button that has been clicked. Let's see if there's something wrong here. So we can go in variables. You see that you have this V object here. So maybe we could look for, let's say, the ID of this object, and it's going to be M, small m, and NID, capital ID. And then you have a number. It's basically like a pointer. It's a reference. It's 2131034116. That's interesting because if I move my mouse over my radio button red here, I have exactly the same value, so the same reference. So yes, indeed, I have clicked the red button. Would have, of course, a different reference, different pointer if you prefer, with the green button. and also a different one with the blue button. So far it seems good. What I will do now is go step by step to see the call flow of my application. You can use this if you want, so it's step into F5. If you want to go in the method or the function itself. We don't want to do that, we just want to go line by line in my code. We're going to use this one. Step over each line of code. Let's do that. It's bringing us here in the switch. Well, that is making sense. And now it's doing this. Good. Turning the text in red. And then, oh my god, it's going to do that. Set text color green. Why that? That's not logical. Well, and then here I'm realizing that what a poor Java developer I am. I forgot to have a break here at the end of my case. So let me fix this. And here you had a brief overview of how to use this debugger, how to set breakpoints, check your variables to see what's wrong in your application. And now we're going to have a look in the logcat. So I will maximize this. It's a logging system. It's kind of syslog if you prefer, with a time, with something. I'm going to see what this something is very soon, with a process ID and a tag, then a message. So this something here, we have I, D, E, W. So the system is by itself logging already a lot of things. You have, for example, here the Delvig virtual machine that is freeing up some memories with the GC, the garbage collector. So it's just debugging what it's doing. It can be helpful. You can also debug your own stuff. So I here is going to be for info. D here is going to be for debug. He here is going to be for error. That's why it's in red, to catch your attention. We have a W here, which is a warning. And so the info is here. I think it's about it. Yes, we have maybe we can have a V here also, which is a verbose debugging for your application. I don't see any here, so one more time you will have to believe me. And you can use this system, this logcat system. You can log your own lines here. I'm gonna show you how to do that. I will go back here in my code here. What you're gonna do is do log dot then the level, this verbose debug info warning or error. Let's say that we want to have a debug here. We can just say D, it's a shortcut for debug. Or you would say V for verbose, I for info, W for warning, and E for error. Here you provide a tag, and which is usually very short, and then a message which is usually very long, or I would say longer. I'm importing now the Android util log class. I'm saving, and if I run this, it's gonna have a line in the logcat file. But what is really interesting is, well, you know, sometimes you're running some piece of code and you're not sure if it's gonna work or not, because you cannot be sure. Let's say, for example, you're opening a file. What if you cannot access the file? Because, I don't know, maybe you won't have the permission to do so. Or maybe you're trying to open the file to write something in the file, but there will be no more space on the SD card, in the memory, whatever. Or maybe there will simply be absolutely no SD card. It's possible, so no space, nowhere to create this file. Okay, in this case, you do a try. You do whatever you have to do here, and you have a catch here, because you know that maybe, if you're lucky, it's going to be okay, but maybe an exception will be raised. Let's name this exception he. And what you can do here is you're going to log something. It's pretty bad if you cannot do what you want it to do. So log dot, so since it's pretty bad, it's going to be an error. And same thing here, the tag, and then your message. But what you can also do, and that is correct, that is absolutely correct, but what is more helpful here is also, because here you will only know that something went wrong and you've not been able to do what's here in the try. In the log, it's going to be interesting to have the exception itself. What was wrong? What went wrong? What has the operating system detected? So you're going to add here the exception, so that in the log you will have your tag, your message, and also your exception. And now let's talk about the ADB, the Android Debugging Bridge. But it's some kind of deja vu, because I think in English I should say déjà vu, because well, it's a French expression, of course, because we've seen that in one of the previous chapter. So you know that you can go on the console and do ADB. I'm just going to make this a little bit bigger, and you have a different set of options here, and we can do, for example, ADB devices, and you see that you have an emulator running. We've seen that we can do ADB -e because I want it to run on the shell, on the emulator. So ADB -e shell, and now I'm now connected on the emulator, and I can use Unix, Linux commands like ls. We've used that in the previous chapter to check some database files. You have SQLite 3 client as well that you can use here for debugging also if you need to. You have a push command, and you have a pull command as well if you want to push files or pull files to analyze them from the emulator or from the phone if you are testing on a phone. What you can use this for also is, and I'm going to exit the ADB tool for now. What you can use it for also is for having an eye and keeping an eye on this logcat. And when I'm debugging, usually pretty much every time actually, when I'm coding also, I always have a terminal opened with an ADB -e logcat, because it's an easy way to see what's going on the phone. So when I do that, it's showing me all the logs, and it's like a tail in real time. If I rerun my application, for example here, and I go back here, see, you see in real time what's going on. So you don't have this little teeny log tail window in Eclipse. I prefer personally to have this this terminal. It's easier for me, and maybe easier for you as well. Now let's go to the DDMS tool. It's a perspective as well. Here we've seen that in the discovery chapter at the beginning. You see that DDMS is attached to the emulator. You see the different processes with their process ID, their size, and the package's names. So you see exactly what's running on the telephone. You can also control the emulator by saying that it's registered, unregistered, it's roaming, it's full speed, it's not. So you can test the seamlessness of your application, making sure it's working well in all cases, even when you have latency that you can set here. You can also simulate an incoming call. You provide the incoming number to see how your application is going to react when it's receiving an SMS as well, if you want. And you can also manipulate also the GPS if you are developing an application that is using the GPS. That is here that if you're using the emulator, you're going to simulate the fact that you are in the US or in Europe or whatever. In this perspective, you also have a view on your code. It's optional, you can close it if you don't need to see your code. And you have the File Explorer, very interesting. You can browse your SD card, your data, your system. You can fetch, push and pull files here with those buttons if you don't want to use the ADB command line. And so you see, I'm going to click here on my application. It's under com.voxisland, and here what I can do is click on here, and then go here in threads, and I see the different threads of my application and their status: waiting, running, native. So it can help you, especially when you have multiple processes, multiple threads within your application, helping you with your debugging. And now I'm going to show you a last tool. It's called Trace View. It's not really a debugging tool per se. It's something that will help you to tune your application. Let's say you want an application to be very efficient, or you have some efficiency issues within your application. You want to understand why and where the system is spending its time. Then you need some kind of what is called a profiler, and that's the Trace View tool. Okay, so what we're going to do is activate this profiling and write some profiling information on the phone, and actually on the SD card of the phone. So remember that if you want to do that, you need to have permission to do it. That's why I'm going back here in the Java perspective. I'm going to open the Android manifest file here, and I'm going to say here that I want to use a permission, as we've seen previously, and its name is going to be android.permission.write underscore external storage. I'm saving my manifest file. And you know what, that would not really make any sense to do some profiling on the Joshua application. So I'm going to change, first I'm going to remove this. I'm going to do something special here. I want here the application to use the CPU a lot. I want the telephone to suffer really. So I'm going to create a suffer function. I'm going to define this function here. It's going to be a public void suffer function, and what I want to do here, maybe I will just cut and paste my favorite suffer function. It's a for 1000 iterations, and in this for loop I have another for with another 1000 iterations, and inside this, so that should be 1 million calls. So 1 million times it will create a k integer and assign I multiply by j, assign it to k. So that is going to be done 1 million times. I like this because it's making the phone suffer a little bit, but just a little bit. This is not going to take minutes, just a couple of seconds, so that we can see what's going on. I just have a warning here because I'm creating a k variable that I'm not using. That is fine. That is fine. So I'm saving this application, I'm running it. It's not ready yet, it's coming. Here it is. So if I click on red, See, it's not instantaneous. It's not a couple of seconds, but still there is something wrong. It is slower than it should be. So let's do some profiling to see what's going on. And here in the DDMS perspective, I'm going to look for my process. Okay, it's the last one here. I click on it, so I can see the different threads here. And now what you can do is click here on this icon, the Start Method Profiling. When you do that, it's going to start your application. You're gonna play with it a little bit, click on the different icons, do whatever you want to test, whatever you want to test, and then click here again, and it's going to create you a trace file and open you the trace view tool. I'm not going to do that here because I want to show you, I did that already earlier, and I want to show you how you can save your results. It's very important to save your results because you're going to make some changes in the code and you want to see the difference, the impact on the performance of your application. So it's going to create some data, and you can grab this data in the file explorer here. See, on the SD card I have com.voxisland.trace that has been created, and I can download this and pull this from the device. I'm going to save it on my desktop, and I'm going back on my terminal. You see here I still have my logcat, so I'm going to open another tab in my terminal, and I'm going to call the trace view tool directly on the com.voxisland.trace that has been created. So once again, it's a method to have to save it and have different profiling results saved on your computer to see if you are on the right track when it comes to making improvements. And here basically what you see is all the different Java method that are called, and the time that is spent on each of them. You have a graphical view, so here you see what's going on actually when moving the mouse on the application Joshua, and when I clicked on the button exactly here, then I have this 1.2 second, I think, yeah, almost 1.2 second of something, and then it happened again apparently when I clicked on another radio button. What is it? Well, I just click on it and it's telling me that it's com voxisland joshua.surfer, which is taking all this time. So it's basically telling you that maybe that's right, but maybe that's not. This function is really taking a lot of time to run. And that's the end of this debugging chapter. Here I would like to recommend you do not spend too much time debugging your applications, and for that you have to be like me, be an excellent developer, and like me, never ever make any bug or any mistakes in your code.